All right, 10.6 is carboxylic acid reaction. So we're going to look at carboxylic acids and see how you can make what you can do with carboxylic acids. Okay, first one we've talked about, or we'll talk about, is the Fischer esterification. All right, this is basically you take a carboxylic acid, you take an alcohol, and in the presence of an acid catalyst, you form an ester plus water. Okay, this is called the Fischer esterification. This was Fischer back in the late 1800s, early 1900s. He won a Nobel Prize. He did the Fischer projections. He did a lot of chemistry with sugars. He was the big guy in sugars. Okay, so the Fischer esterification. Let's look at this mechanism. It is a lengthy mechanism. We'll probably go over it a few times. The first step is your carbonyl grabs the acid. This is acting as a catalyst. All right, it's an acid catalyst because it makes that carbon much more partial positive. So notice you have an oxygen with a plus charge. That oxygen is not very happy, so these pi bond electrons are going to want to stabilize that oxygen. And it puts a plus charge basically on that carbon, which now that carbon becomes so electrophilic, your alcohol can now easily attack that. Make sure you know this mechanism. Hint, hint. Backwards and forwards. Well, not really backwards, but make sure you know how to do this mechanism. All right, and then, so now you have this. Now what happens is a proton transfer. This hydrogen gets transferred onto this. I'm doing the wrong arrows. Sorry about that. This oxygen grabs the hydrogen, and you basically transfer the hydrogen on that oxygen. Remember, we talked about that water is a really good leaving group. Anytime you can make water, you're going to want to do that. So what happens is the lone pairs from this OH come back down and kick out your water group. And you can kind of see how you're already making your ester, and then that water comes by and plucks off that hydrogen to regenerate your acid catalyst. Okay, so that is the Fischer esterification and a reaction with carboxylic acid. Okay, what I would do if I were you is I would now turn this off, and then I would try to redo that mechanism on your own. Okay, try to ingrain this mechanism in your head. That's one reaction. Another reaction you can do with a carboxylic acid, which we've talked about, is you can add LAH to it in the presence of acid. I'm sorry, it's a two-step reaction, and you reduce it to the alcohol. Another one, which is very important, is make it into the acid chloride. How do you turn this into an acid chloride? Well, SOCl2. We've learned that if you take an alcohol plus SOCl2, you can turn it into a chloride. Well, you can take carboxylic acid and add SOCl2 and add it into an acid chloride. All right? All right, section 10.7 are acid chlorides. So, like I said, acid chlorides can pretty much make everything. So again, just to remind you, to make an acid chloride is you start with the carboxylic acid. Remember, you can make everything from the carboxylic acid. The acid chloride is the most reactive one. I mean, you can take an acid chloride and you can spit on it and the thing will react. So let me show you. You can take an acid chloride, right? If you add a carboxylic acid to it, that makes the anhydride. So notice basically what's going on is you're replacing this group for whatever your Cl is. Okay? The hydrogen and the Cl pair up. So anytime you add a nucleophile, the hydrogen is going to come off and pair up with the chlorine, and the remainder of it gets in place of the chloride. Okay, so that oxygen on the carboxylic acid attaches on it to form the anhydride. Okay, so this group right here is that part of it. Okay, if you add an alcohol, so ROH. Okay, if you want to put this on pause and predict it yourself, that would be great. So put it on pause right now. All right, to make the so this makes the ester. All right, this part of it just replaces the chloride, and then the hydrogen and the Cl pair up to form hydrochloric acid. Add water. Remember, water is HOH. What are you going to get? Put on pause. You get the carboxylic acid. Finally, if you add RNH2, put it on pause, predict it. One of these hydrogens pairs up with the chlorine to form HCl. So like I said, acid chloride can make everything. It can make the anhydride, can make the ester, can make the carboxylic acid, and can make the amide. Okay?